Okay. So let's see. There's, I'm going to start by looking at the pending proposals. I didn't, doesn't look like we have any new pending proposals. So we've got this, which has an FCP that I think is completed 2 weeks ago. So I guess we can just close it at this point. And type says const parameters. I don't recall, but I think we had a pending RFC there too. Okay, just finished. I believe we decided to close this, right? Yes. So I'm gonna go ahead and do that. And similarly here, I'm just gonna close this, I think. I'm waiting for, like, all right. Very good. In terms of updates, I have at least one. I don't know if other people have any. So in terms of active projects, const evaluation, async foundations. I don't think there's, I'm not caught up to date on const generics, but if someone is in this meeting and wants to give a chat, that's fine. For project safe transmute, I asked for an update, but I never checked if anything got posted.
There is an update posted, and I think it's very clear on what has changed since the last work. The whole here mechanism has been dropped, and the simplified into just a trait. The notion being this doesn't inherently solve the problem of whether you want to be able to privately safe transmute or publicly safe transmute, but that's not a problem unique to safe transmute. That is, in general, sometimes you want a private trait impl and sometimes you want a public trait impl, and one of these days we should solve that. But in the meantime, there are workarounds using new types.
Okay. Muckable doesn't seem like it. Is that a working title?
There is a long bike shedding thread on Zulip right now for what exactly that should be called. The notion is you need a trait to a mean. I'm willing to commit to the byte layout of this type being stable. And so there's a lot of discussion about how exactly that should work.
But the idea is basically that you derive this trait in order to opt into that level of stability, right?
Yeah, that's the idea. And I posted in the Zulip, but giving it a weird name is good because any sort of normal sounding name would probably promise to people as a preconceived notion something that it doesn't actually promise. And so giving it a weird name forces them to look in the documentation to see exactly what this trait is about, which is probably good with this sort of thing.
Okay, I find that somewhat persuasive, somewhat unpersuasive, but yeah, for the idea that weird names will force people to look instead of guessing, I'm not exactly sure, but it might be true. But okay, leaving the name aside, I'm in favor of this shift, I think. The neglect stability, that's fine. That's be later discussed, I guess. But basically, yeah, so the idea is you derive this trait and you are kind of opting into what people can do with your type, including creating it from raw bytes. Okay. Someone who's typing is loud. I'm going to mute randomly until I find you. Okay. So the thing I wanted to note was, or are there any more comments on Project Safe Transmute? Or are we all set?
Does this imply that the macro is also disappearing?
Good question.
I believe so, yes.
Because that had a bunch of interesting API consequences, and whether it should be a macro, where the function should live, etc. I can ask that on Zulip.
Yeah, ask it.
We can move on.
Okay. So I wanted to bring up the never type stabilization because we hit an interesting, we kind of got the lint up and working, but we encountered these false warnings, some of which we knew about before, but some of which I didn't. This was one that I did know about before. And you can debate whether this is the lint working as expected or what. So what happens here in this call to parse, so this line of code gets a warning with this lint. And the reason is that this type T is unconstrained. It appears in the return type. And the reason it's unconstrained is that basically that's the OK type. This is essentially a result. That's the OK type. And this function never generates OK. So it can be literally any type. And if you didn't have the question mark, you would actually get a compilation error because it's unconstrained. But because of some weirdness in how question is desugared, it winds up getting unified with a fallback variable. And so it falls back to never type. And that's like changing under this lint. So it's not wrong. Like it used to fall back to unit. And now it would fall back to never. Are you all still there? Yeah, okay. Then the only other question is, or that's one pattern. That's the one I already knew about and we've seen before. And I think it's kind of potentially good to get a lint here because, as I said, this would be a compilation error, but for the question mark. But another one pattern that I was less happy with is this function. And what happens here is that this closure winds up, it always panics. And so its return type winds up falling back to never. And then that becomes the return type of with opt. And the compiler doesn't realize that this function call is still live, or it considers this function call like potentially live to terminate. And then it says, well, the type of this function call is some type variable that fell back to never. And yet we weren't sure that it is dead code, and that's weird. Maybe it leaked out. So I think this may be, well, we'll have to keep iterating a little, and maybe like we can refine the analysis to consider a function like this dead, but it's not very clear to me yet. So those are two of the cases that the current analysis flags that I think it shouldn't. I believe, well, actually I realized we didn't retest this, that it does also flag the case we're looking for, which is this case. But yeah, so we're working with it. One thing I wanted to bring up is, I think it's my expectation that this lint will just stay on all the time. That it's basically warning against, the fallback is intended to trigger only for type variables that are confined to dead code, but sometimes it affects type variables that leak into live code, and you kind of want to be warned about that because it's weird. But I'm not sure if other people share that expectation. Any thoughts or comments?
Feels like I'd have to write a bunch of code and see when it actually showed up at me and if I appreciated it or not.
Yeah, that seems plausible. It's hard to tell. For now, what we're going to do, I guess, is the next step is we annotated these code with explicit type annotations, which makes the lint go away. And we will, I think, do a crater run to try to get some sense of how much code is affected and if there are other patterns we haven't seen.
Actually, that's a good point, that this would, assuming that this lint is successful, it would lead shortly to stabilization of never. And if we have a stable never, then the way to silence the lint is to annotate a explicit exclamation mark type somewhere. And that seems like a good thing if you are inferring an exclamation mark type somewhere that's non-obvious.
Yeah, it's work. It could be work. Right. I think the question is going to be about how often it happens, ultimately. But
True.
I would like to at least this case. I don't know. I have to think about it. But that case really galls me because it's like it's just it would be nice if it worked. I don't know. Not sure why it galls me so much. I guess just because it's literally doing what it's just returning the type of disclosure. Like everything is working as designed, but we're getting a lint warning. So. All right, moving on. Are there any updates for inline assembly or instruction set? I guess no. Okay. Very good. This, in terms of meetings, we have this meeting proposed, RFC 2580 for this Wednesday. I did do a write-up, although I have to update it with a clearer point of what the agenda is. But basically the plan is going to be to, I think it's linked here. I guess not, I put it on Zulip. I'll throw it in the issue as well. But right, I think the idea is we're going to cover a little bit of what the RFC says and then talk about some of the future possibilities and how they would affect the RFC or not. All right, let's move on. So nominated RFCs, super trait item shadowing. I wanted to follow up with this. I think we had a plan to FCP merge here, but I don't think it ever happened. Scott,
you're right, that's on me.
The other thing I want to say is from the backlog bonanza, I said I would go and assign things to people and I didn't, but I will do that. Or people can just go pick them up if they want.
By commenting on the paper doc, I think that's what we're going to do there. Yeah.
Yeah. Yeah, I know Felix, you followed through on a few things, which is awesome.
Not nearly as many as I'd hoped to. Yeah.
All right. This is the PR that we're going to skip over this. This is the Mark is working on implementation. So we'll go down to nominated PRs. We've got a lot of them, or issues. So operators in patterns have incorrect priorities. Rough 48501. Scott, you nominated it. Do you want to talk about it?
This came up as thanks for putting the note in the agenda about around stabilizing ... equals. I don't know how we feel about these things, but if we want to tell some, but since we said last meeting that we'd like a stabilization PR for ... equals patterns, it would be kind of mean to people to say, oh, whoops, actually we're not ready to stabilize because the precedence is wrong. I haven't thought particularly strongly about whether the pattern as it is right or should be changed. But we might want to change the help wanted in the other one if we're unsure about this one.
It seems pretty clear to me that the pattern is wrong, but it's also stable. Or like the pattern is probably the most convenient. I guess whether it's wrong or not, I don't know. It's not great that they're not consistent, but the pattern behavior is stable and like we could lint against it, but I don't think we can just wholesale remove it, right?
I guess one answer is we want ... equals to be the same as ... in precedence wise, and if we're going to change one, we'll change both, but that would be a addition dance anyway. So if we're going to stabilize ... equal, we should just do it with the current precedence.
That's actually my opinion, yeah, that they should match. I think that the precedence of ... and ... equal should match in general, and we should address this pattern question probably by suggesting parentheses to make the meaning clear or something. Does anyone not agree?
Presumably that's the current behavior, right? If like you, for the unstable and stable bits.
I assume, but I haven't tested that assumption. I guess we could test it right now.
We should probably move on.
Yeah.
It does seem like in most cases, the thing we'd be linting against is also something that really shouldn't parse. So, or rather, shouldn't type check?
It doesn't, no, the problem is in the pattern case, it does type check because it's actually a more useful interpretation, even though it's not.
No, that's what I mean.
Expect.
I'm saying the version in the expression should almost never type check.
Yeah, that doesn't, and you don't really have to worry about that case.
Well, you might actually, because it would type check if you had an open bound, like ampersand 0 ... could be a range from where the lower bound is a reference.
I see. That's a good point. Yeah.
Hopefully nobody's doing that and there's no compatibility issue, but it is relevant.
So what are we, when we talk about linting against, we talk about linting against the pattern case, the expression case?
It's a good
I was
question.
talking about patterns, but you're right that we really ought to clarify that. I don't know. I'm not really strongly feeling about linting. Like, this seems like, I don't think this is a quirk of our grammar, and I would prefer if it would be clearer if people put parentheses, but.
Yeah, I think all we're saying here is we don't need to address this PR right now as part of stabilizing the other thing. But if someone wants to look at this and figure out a better way to do things, then that sounds great.
Yeah, that sounds about right.
Yeah, sorry to be pedantic here. The bullet of precedence for ... and ... equals should match in all contexts. That implies that if ... equals doesn't match today, the precedence in these two, like it doesn't actually have these differing two behaviors, then ... equals should be the thing that changes to be more like ... and have the context dependent behavior, right?
What I'm saying is ... and like, I'm saying that if you're in an expression, 0.10 and 0.equals 10 could be the same. And if you're in a pattern, they should be the same. And ideally, expressions and patterns should be the same with one another, but that's what we've already lost. Those are like two of the separate things, right?
Right. I'm trying to ask who loses, which part breaks, which part has to give way to satisfy this constraint of they should all match in all contexts. I'm assuming the point is ... equals should be the change.
It should just match what ... does.
Okay.
So it would work in the same way, in the same context where, or like, so and 0, ... equals 10 in a pattern would be.
Okay, thank you.
Yeah, I think that's correct. If that's not the case, then we shouldn't. That's what I'm contending. I could see an argument the other way, but. Basically, yeah, I think this is what Scott was saying, right? We would like to resolve 48501, but that's orthogonal, and we should do it for both ... and ... equal at the same time.
Oh, sorry, I was muted. And what we're willing to stabilize is ... equal patterns with the same precedence as ... patterns.
Right.
Regardless of all the other potential precedence problems, that's what we're willing to stabilize right now.
That's my opinion, especially because I think they're used far less frequently. So, like, we've already got the big problem. I guess that's not. I guess patterns people use both pretty commonly, now that I think about it, but in expression form, certainly not. All right. If nobody objects, we'll move on. Now, I think this, so for tracking issue for x ... blah, blah, this is the sort of we were just talking about, right? There was some comments around adding more aggressive lints. Like this comment by Digsy, suggesting that we should suggest replacing underscore with open-ended patterns in order to help people see if that's not the semantics that they actually wanted. I feel like that's an orthogonal and interesting idea, but not something that would prevent us from stabilizing. Agreed?
Yeah. Agreed, and people can experiment with lints or clippy lints or make one and propose it and see what the fallout is, etc. The usual.
Scott, can I lean on you to like follow up on these two issues since you've been...
Deal.
All right. So next issue, Rust 72209. This has been FCP merged since September by Scott also. It says, as it says right here, it basically makes the unsafe code lint also complain about these link attributes because they can cause unsafe code to, they can cause problems where you like overwrite main or whatever. There was a, oops, didn't I have a nice, oh, here we go. There was a crater run done, it has relatively limited impact. One regression, I guess. Meaning this, of course, since this is a lint, it won't break any dependencies anyway, but this affects not that much code in the real world, I guess, is the evidence. So it looks like we are in, I'm not sure why we're not actually in FCP now. Maybe we just need to jigger the bot now that I look more closely at this. But Josh, or if you or Felix want to check your box and leave a comment, that might move it along. Any comments on that? Okay. All right, switch, mutable, borrow, reservation, conflict. So this is the issue around pre-existing borrows and two-phase borrows and their interaction. It's been nominated for a little while. I wanted to call attention to the last few comments around here. Basically, it's kind of hard to summarize them, though I made an effort. So I'll pull back to here. Sorry, I'm switching screens so much, but the summary is, when we did this initially, Ralph felt like stacked borrows could handle two-phase borrows, but for this restriction. But then he decided that's not the case. They don't have the, then he wound up like pulling back to, so that two-phase borrows basically are kind of like a raw pointer, which means you get less optimization, but it also means they're compatible with this pattern. And we did do some crater runs that found a fair amount of impact. 117 crates would be affected by turning this to deny by default. So, and even when we did it, we felt a little bit of uncertainty because people like, I don't know, this pattern is sort of not that uncommon, easy to do, it turns out. So I don't know, we have to decide what to do. I think going to deny by default is not obviously the right step here.
Yeah. The original motivation here was like, we think we want to change the model. And based on the comments from, I don't think we should be like aggressively pushing back against it without knowing what the model might want. I think I personally would say either we should keep the lint at its current level of warn, or we should drop the lint to allow for the moment until we get further into like, should stacked borrows and aliasing, do they want this restriction? We added it because we thought we might need it for stacked borrows, but I don't know that we should do that indefinitely on the basis of, well, maybe we shouldn't allow this.
right. I'm somewhat inclined to move. Like, I don't love leaving it at warn indefinitely. I might rather either remove it, just accept that we're going to do this pattern, or
alternatively accept that it's going to be painful if we decide to stop doing this pattern, which it's pretty clear with 117 regressions, it is going to be painful if we decide to enforce this as a non-pattern, even with the lint we put in place.
Right. Moving to allow by default seems like you might as well just give up. And accept it.
Yeah. I think honestly that's what we should do.
I will note that it looks like, based on the actual report, that there's actually only 2 root crates, and most of the crates are actually spuriously regressed, if I'm reading the report right. So it's not like that horrible.
Oh yeah, maybe I didn't.
But I might be reading it wrong, so I would need to do sort of more investigation.
Yeah, okay. I'm not sure how much I did in terms of that. In fact, I'm pretty sure I didn't do any stuff. All right, maybe somebody can look at that report in more detail. Yeah, that seems important. It affects my opinion a lot. I will try to do that. Okay. Use dep1 foo as dep1. So this is, we've been going back and forth on this. And at the last meeting, sorry, I gotta mute. Okay, so at the last meeting, we had decided to revert back. If you remember, we had this, we thought we should revert back to the older pattern. I left a comment. No. Because there was some regressions, but then I started digging a little more into this, and I just wanted to call up and show people why Petroshenkov had instituted this rule. There is a property being lost here that I think I had thought we had. The example is kind of hard to wrap your brain around, but this is the relevant example. And so let me just try to explain it. What happens is this code basically is not expected to work, but it does. Or you might not expect it to work, but it does. And what happens is, first, it imports all the names from foo through this glob at glob precedence, which is lower. So it imports foo bar, right? Then, at that point, these imports are able to trigger, and this imports bar, which is foo bar. And that, because that's an explicit import, that overrides the precedence of the glob. So now the name bar in this root scope refers to the inner bar and not the outer originally did. And so then we're able to resolve bar foo bar, which otherwise wouldn't have been resolvable, and thus can use foo bar. I guess this doesn't actually use it, but so that's a little weird. And the property that this violates that I kind of had in my head is like, at the end of resolution, you're able to say what each name in each scope maps to, and then kind of recheck all the paths to make sure that they still match. So like here, if we said, okay, bar maps to foo bar, then this would be an error because you can't resolve bar inside of, there's no third level of barness, so to speak. But that's what people say, or that's what I thought of as time traveling. But as Petroshenkov called it kind of import resolution as inference. I think that's what he was referring to. So Yeah, so that's the property that we're losing. And instead we're having this notion where like you have to take into account kind of when we resolved it, what you knew at that time. Which is a little wacky. So this bar and this bar are not the same bar, in other words. But it is respecting, as Petroshenkov called it, causality, where like there's only one bar they could have been to make it make sense. And one way I thought about this, if we did want to accept it, is that there's again a sort of elaboration step happening here, where this is like because these uses are kind of shorthand form, and the more explicit form would include like colon foo colon bar, I guess, or self colon and things like that. But I don't know, it's a bit of a hand wavy justification. But so I guess the question is, do we mind giving up on that property in exchange for continuing? I mean, we don't want to break code, so maybe we don't have much choice. But I wanted to bring it to everyone's attention. I don't know that we're breaking any code that's like totally unbreakable, but I also would like us to get stricter about not breaking code, so I'm torn.
I mean, the flip side is, what massive thing do we gain by breaking this?
What does breaking this mean? Sorry.
If we were to it seems like we would want to avoid making a change that will create this level of regression. I'm trying to figure out if this is just a trade-off of this is difficult, or if this is a trade-off of we're going to break one set of things or another set of things. And it seems like it's more the former.
It's more the former. It's just name resolution gets that much more interesting. Or like some simpler models of name resolution we might have pursued are not available to us. I don't think it breaks anything in terms of there's not code that would have compiled. I think it accepts more code. There's a meaningful interpretation to more code. It's just that it's a more complex model for people to understand, or probably most importantly, the compiler to understand, but maybe people too.
I still feel inclined to say that, like, if we were to break something here, and I'm not entirely objecting, like, it does feel like there is sort of confusion, at least potential confusion here. We would want to do so in addition to boundary, and in which case we sort of have our hands free to do so at a later point. For example, with like Petroshenkov's inference idea, which presumably would break a lot more than just this. Yeah,
I'm somewhat inclined to agree, and I want to have a nice model, but I'm also not sure that this can't lead to a nice model, for one thing, and second, it works. We can, like you say, we can try to do it over an addition, or in some disciplined way if we have a model that we want to move to, like NLL or something. All right. I guess that means I don't hear anyone else. I guess I'd like to hear any contrary opinions if there are any.
Would there be value to trying to at least detect instances of this pattern and int them to stop more code like this from forming?
I don't know. I don't want to, but I'm trying to figure out why. I guess just because I feel like I don't want to be trying to have it both ways. But,
well, that would be a first step to doing the addition change if we wanted to do that, right?
Right. Yeah, if we wanted to do the addition change, we'd have to have a lint and we'd have to suggest rewrites to like a more explicit form. That certainly wouldn't be terrible, just for clarity's sake. Like, it would be nice if this code were rewritten into absolute paths, right? Be much more readable.
Yeah.
Maybe that's a good idea.
We did talk about that back when we did the 2018 edition. We suggested we could have a lint for use A : B, use B : anything. We didn't want to lint for like use A : B and then actually using the path.
Yeah, specifically I'm talking about
starting with B elsewhere.
I'm specifically talking about these kind of time traveling cases, which I think
Right.
can only occur when the glob precedence is, like, I think they have to, because we only have one level of precedence, they kind of have to occur around globs. Maybe around prelude or something, but like. I do think, I'm wondering if there's I guess I'll talk to Petra Sinkov if there's some possibility of ambiguity here where if something could have resolved either with the glob name or with the fancier name. Hopefully we catch that case, but. Is someone going to leave a comment about this?
I can do that.
Okay. All right, next one. Built-in implementations of default. So what's being proposed here, actually I won't jump over all this since I kind of wrote it here, is that for zero capture closures and for function, top level like function items, the special unique types that each of them have associated with them, for those two cases, we could make those types implement default. And the motivation is that it would be nice to be able to write a generic wrapper like this that wraps a function like that and does something before and after it gets called. And if you want to do that, and you can do that with a closure, but then you're taking in, well, you can't write it generically, and you're taking in or you're taking a function pointer or something, and then you have state. If you just want a plain function pointer, this is rather more convenient. At least that's the argument. And although I'm not sure how.
I can give more context on that if it would be helpful. But,
yeah, sure. I'm wondering now how you would actually call this, because you would have to use Turbofish to like tell what.
So
but I guess you can.
In my case, I'm using it with async code where async closures don't quite work the way you might expect, and so standalone functions are the only option. Yep. And I'm able to call it because I do actually have an instance of the closure that's being passed in, but I don't have access to it at the point where the thunk is needed. So I basically get the type from when I have the closure, and then that type gets type erased later on. If that makes sense.
Yeah, I think so I can imagine that you could do something like, something where you have something that makes the wrapper essentially. You is able to give a name to the type at that point.
Yeah, it's almost like a custom vtable.
Right. But yeah, so basically the idea is to make them implement default. This is done in the compiler. It makes default a well-known to the language, a lang item. There was some proposals for alternatives, like using the function pointer trait, but I don't think that works because that trait was meant to be implemented not just for zero size things that can implement default, but also a bunch of other things You could do some more general trait though if we wanted.
So sort of an odd thought I had on this one. Would I expect closures to be default even if they were non-zero sized, if all the things that they closed over were themselves default?
Good question.
Because closures are copy if everything they close over is default, and clone if everything they close over is clone. So if I imagine this as like a derive on the actual closure type.
I really don't know. It makes total sense for me for clone. It makes a lot less sense to me for default, although why? I guess I think of closures being very linked to like the state at the time they were created or something.
I didn't include that in the implementation because you don't know that what was bound to the closure was actually constructed by default. Like it could have special properties that are, things that were bound to the closure could have special properties that the closure depends on. So just constructing them with default could do anything really.
Yeah.
Right. It's sort of weird, but it would kind of be consistent at the same time.
Well, I mean, it seems like a pretty good point that you could just generate random panics because the closure might be only ever created in the case that like an integer is greater than 1, right?
Right, or it captured a vec and it's expecting the vec to have some things in it, or any number of things that I can imagine this would be silly, but it just sort of.
My intuition here is you should like to get that kind of property of the, the default if all parts are default, it had to be something you opt into. Like you have to have some syntactic way of tagging the lambda expression to say that we're getting that in this case. I wouldn't want it by. I wouldn't want the default.
And there's a case to be made. So closures, because closures are generated by expressions, right? There's a case to be made that's like, well, okay, even if they don't have any upvars, maybe still you wouldn't expect this closure to exist unless some state had been entered or something like that. But I'm not sure if you could even get the closures type without that, but like I'm imagining the closure only has side effects. Maybe it prints something to the terminal, but you only want to print that if a certain thing has happened, and maybe and then you would create the closure, and maybe with it using type inference tricks or whatever, you can kind of instantiate the closure outside of that if this way. That's sort of the analogous case, right? Although it won't panic, it may do what you don't expect.
I think part of what I'm thinking here maybe is that maybe this bound is better expressed not by default, but by safe transmute from unit or something.
Yeah, I think sort of my thoughts on the PR thread were sort of similar, that default just sort of feels like it, to me, default is not what I think of as new, if that makes sense. Like it's not the zero type constructor. It's different, like it implies something more. And I think that sort of in general, it's not what I think of as something closures having. But I think that sort of depends on how you think about closures. If you think of them as just sort of a special struct with some special impulse, then that sort of falls away in some sense.
Because I think I might say that as it's notable here that the use does actually have an instance. So it's not trying to use default to get more instances exactly. It's trying to have a bound that allows it to transfer the instance without transferring state, if I'm understanding things correctly, which feels like default's semantically not the right thing.
Yeah, I don't know what I think. Sometimes I think of it as just new, and I've even thought maybe we should have called it new, but other times I don't.
I think it's more obvious to me that it would be reasonable for function types to be to automatically be safe transmute to and into and from unit or some other canonical ZST.
I don't know.
And then
strange to me.
Shouldn't function types transmit to usize?
So function types, not function pointer, not FN types, sorry.
Voldemort
function types.
Capture-free anonymous closure types.
Well, and functions, because functions also have that type.
Yeah, okay.
Which is, I think, what's getting used here because they mentioned that closures, async closures didn't work right for them for some reason.
Yeah, function definition is kind of the... I feel differently about closures and function definition types, but I'm not sure why. I guess just because functions are like, anybody could call them from anywhere, but not anybody can create a closure. You have to execute that expression to make it. I don't know.
I suppose it depends on whether observing the type of a functional closure gives you the right to call it or not.
Yeah, that's kind of the question I'm getting at. It's not obvious to me that it does.
Yeah, that's
not just the ability to call it, but the ability to create it. Yeah.
Yeah, that summoning instances from the ether is not necessarily something that makes sense here. That the same smuggling it through some other storage that allows for the representation of the same number of valid states would be okay, but that creating it from nothing is not necessarily okay, even though it has only one valid state, which is the same number of states as nothing.
I mean, I think it's just confusing. Like, it's sort of the issue.
Yeah, this seems like it's a workaround for, like, it only works for specific types of closures that don't capture anything for obvious reasons. But if you have a closure that doesn't capture anything, we already have a way to turn that into a function pointer. I'm wondering, is there some way that we could... It seems like this is working around not having the ability to just manufacture new functions and ship them around. And rather than having this, which seems like it will always generate incredibly confusing code, we should just look at actions.
I don't know what look at actions means, but I would like to move on from this topic. So maybe maybe we can move some of these points to the thread and elaborate there. Someone volunteered to move some of this over there. I feel like I don't remember all of this being discussed there, but especially this question. But
I feel like we don't have a consensus, so sort of people who said things should, including me, should go and post them on the thread so that we avoid new rationale.
That was kind of what I was getting at, not try to post a consensus, just a summary of points. But... All right, that's fine. People can post their own thoughts and or comments. I'm just going to leave myself a note to do that. 7, 6, 8, 8. Okay. Next one. This is an FCP. Okay. So Scott raised this point about repro transparent and temper, which is a good catch. And I think a good lesson for us layout things this comes up, but the problem being here we have a type that is empty. Here we have repro transparent. This is only allowed if these things are all all alignment 1 zero size types, these things being everything other than the main value. So now if crate A adds fields in here, which would otherwise be allowed, and in fact they signaled their desire to do so, then this crate B will break. It's a problem. It's annoying. certainly related to the stable layout transmute questions, I guess, but related but different.
Yeah, my first thought here of why I explicitly filed this mentioning non-exhaustive is that it seems like we should clearly not be doing this with non-exhaustive. And then as we get safe transmute, the conversation about like the muckable trait or some variety of things like that, say to me, would give me the, oh, if you said it's muckable and it's a ZST, then you'd be allowed to use it as a 1ZST because muckable prevents you from changing that. But otherwise, we'd just not allow this in Repro Transparent. But that would be a separate thing to me from the non-exhaustive conversation that seems more obvious about, oh, we should just never have been allowing this.
Yeah, I mean, one thing to note is that this isn't the only such case, right? Like you can also pattern match against it, can't you? If all the fields
not if it's non-exhaustive.
I know, but without non-exhaustive.
Yeah, without non-exhaustive, things go weird.
So indeed, like non-exhaustive is the.
No, because if you add one private field to it, you can get sort of non-exhaustive that avoids all of those patterns and creation things. Basically the old way of doing non-exhaustive, and this would still happen.
But you can still assume that it's zero size, so I see, yeah, okay.
Yeah.
Well,
that was the first thing I thought about in the Zulip thread, but then non-exhaustive jumped to mind as more obvious.
Yeah. So, right, so to highlight the key points here is like, with non-exhaustive, this is definitely undesirable, but if you have a private zero-sized field, you can get a similar pattern. So, because plausibly we could add a check that says like, kind of adding the check of, it's really getting in exactly the same issues of safe transmute, but plausibly we could add some kind of check based on, is it a publicly visible set of fields and all that kind of stuff. But
yeah, it feels like a lot of the same non-exhaustive conversation because we probably want, no, it's okay inside your own crate, the same rule that non-exhaustive has for this, etc.
Yeah. I would definitely accept it. I would encourage a PR that adds this check for non-exhaustive at least.
Do we have any intuition on if we'd be willing to just break that?
Well, we could do it for non-exhaustive. I suspect the impact will be very small, but
it does seem very unlikely that there would be any good reason for someone to put such a type in a non-exhaustive, in a Repro Transparent.
We could certainly do like, right. I mean, I think a future compatibility warning would be an option too if we're worried about it, but, and just turn it into a hard error later on. The question is more, this is the more interesting case to me, is do we want to go past non-exhaustive? But maybe we just start with that.
I guess go ahead, Buzz.
We should, I would think it would be bad that, well, I guess maybe my perspective is that I didn't realize non-exhaustive could be applied to structs until this conversation. And I've always, when I want to like reserve the right to add fields to a type that currently has no fields, used a private field, like a unit field.
Right.
I think that it would be bad for that to be the incorrect, like like meaningfully incorrect, right? Like you need to use the non-exhaustive attribute, or you have not correctly marked yourself as Semper for the future.
Right.
I don't want
to agree with is that this was the standing pattern for a long time and arguably still is, right?
Yeah. So I'll propose that I make a new issue for the version with parent, the non-exhaustive version, and we come back to that after safe transmute has made a little more progress as where we want to figure out how we want to fix that one.
Can't we issue one? Okay. I guess we
could lint about that one as well.
We could certainly lint about it in other crates, right? If it has private fields and it's in another crate. Like,
okay, so say on the existing issue that help wanted, we'd like a future incompatibility warning about this or the you included a private ZST cases.
yeah.
And then we'll see how bad the impact is.
Yeah, I'm wondering. We don't know. Yeah, I'm really wondering what we will find. Like, I could imagine people have private fields with phantom data or something that they did not intend. Like, just having a private field is not a clear signal that you will potentially add more things. But yeah.
But it would have to be a type with a phantom data and something else that is ZST, right? Oh, you mean just a type that is only a phantom data?
Yeah, that's an interesting point. Yeah. But I mean, then, I don't know.
Yeah, I guess I would appreciate a link that we could do a crater run on, basically. Get some idea of what we see.
Lint, future compatibility warning, or don't care?
I mean, there's not much difference. I would, like, if we're talking about exploring, then we can just start with a lint and turn it into a future compatibility warning before we land it. But
okay,
it's basically
cool.
a category of lint. So
I'll help wanted this one then.
Okay. I do think the non-exhaustive case is pretty clear-cut, even though I also agree with Boats that it would be good to cover more than just that. All right, well, we're about out of time. The last, yeah, I guess we're out of time. Almost made it. If people want to weigh in on renaming overlapping patterns or applying unused dot comments to inner items, please do so. But there you go. Thanks, everyone.